card?
Go for it, so.
Oh.
I think it's a mammoth.
Oh.
I've heard a lot of jokes in my day.
Yeah. Or ate lots of laughing at me. Come on, you.
I like the banana ones.
Those are my favorite.
I was afraid I was going to get a lot of hate for saying that.
Hi. Who is that?
That's Ratchy.
Ratchet.
Hi.
Oh, he does look like Ratchet. His big ears.
Yep. Little old man. Okay. Are we sharing this? Share? Okay. Okay. So I posted the rest of the notes for the rest of the year on Moodle. I checked last night, and apparently they got out of order. So I don't know what happened there. But all the notes are there. Because I thought we were going to get completely kicked off campus. But they're making exceptions to us. But I need to figure out how to make sure it's okay. So if I get stopped, that I'm considered still essential for the job. So, but yeah. Thank you. Okay. So, oh, chat. Let me get that open too. Who needs help? Okay.
You
Okay.
got a message, Joni.
Yes, I see that now.
Okay.
Megan, make sure I got you. Megan, there we are. So Austin's not here yet, right? I don't see Austin. I think that it's, and Michaela's not here, but that's because she had a family emergency. Let me move this to this screen. So that way you can see it. All right. So this is the last section. Sorry. Last section of chapter 14. So they're going to be talking about volume and other measurements. I added a section on time because I know that that's something we definitely teach. But the book didn't have anything on that, which I thought was kind of weird. And since we were talking about unit conversions, I thought that was important too. So we can talk about those. So in this section, we'll see representations and connections. And then, of course, content is geometry and measurement. This is going to be 1 through 8. And then you'll see some relationship. There we go. In 6th and 7th grade in terms of algebra and then, of course, their geometry. So in this section, we're going to talk about volume as opposed to surface area. So this is going to be talking about how much something can hold versus how much we need to cover something, right? So to find the surface area, count the squares, but then to find the volume, we would count the number of cubes. So like here, this would have a volume of 1, but what would its surface area be if this was a unit?
I can't really see.
Hmm?
I can't really see.
Oh. Focus. So do you
Also,
see the,
if the lengths are 1,
yeah, so if this was a unit cube, what would its surface area be?
6.
6, right? Because we'd have 1. There's 2, 2, 3, 4, 5, and 6 sides, right? Now, what if we were looking at this one? So I have these stacked on top of each other, right? So I have 1, 2, 3, 4 cubes, and it says that I have 18 squared units. Is that true?
Yes.
But this one has 6, so shouldn't we have 24?
Not if they're touching.
Right, because I won't see the surface underneath this one. I won't see the top surface of that guy, and I also don't see the side surfaces of those guys.
So would you just count like the middle one as like a rectangle?
Well, because this one would have you would see this surface, right? You would see
Yeah.
its under surface, and you'll see its backside. So that one's only counted as 3.
It's like
Okay.
if you're wrapping a present, you won't wrap every individual cube. You wrap it like that.
So
Got you. Okay.
I'm only talking about what you actually see on the outside. So like this one, you will only see 1, 2, 3, 4, and then the backside 5.
Okay.
The same thing with that one. And then this one, you will see 1, 2, 3, 4, 5. Now, this would have been awesome if I was able to give you all some cubies to stack so you could actually count those. Now, let's try this one and see if we can visualize what's going on here. So how does the volume for these two guys compare? Oh, I want my book. So what do y'all think?
There's the second one has one more.
Has one more
I
volume?
think so. 1, 2.
Wouldn't the volume
Wait,
stay the
one,
same as the
Wait,
surface
no, they're
area?
the same. Sorry. I was thinking where
Yeah,
the
they're the
bottom was
same.
floating.
Yeah, so if I just counted the cubes, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So they're the same, right? Where's my nice pretty colored pen? There it is. So they're the same. But what about the surface area? Does one have a bigger surface area? So we might want to know what those are, right? So what would the surface area of figure 1 have?
Wouldn't the second one have a bigger surface area because that one side isn't covered? Where the blue, see how the blue one and the first one's touching that
So this
one?
one should have this
A
side
bigger
was
surface
covered
area.
and that side was covered. So we think that they'll differ by how much?
2.
2, yeah.
2. All right. So
The first one has 29.
29.
Yeah.
Did everybody else get 29? I got 27. Did I count that right?
You probably did. I kind of did in my head.
So this one would have 5. This one would have 4. This one has
I got 27 too, Joni.
5. This should have
4.
4. This should have 5. That should have 5. This one has
No.
2,
That second one that you put 5 on?
right?
Yes.
4. This one would have 1, 2, 3.
Uh-huh.
And the one underneath, that corner one, would have 1, 2, 3 as well.
Uh-huh.
So 5, 4 is 9, 13. Oh, I forgot the one that's sitting underneath that one too, right? That one should have only 2 back there.
Yes.
The one that's sitting under the blue cube.
Yes.
So 5, 4, 9, 12, 15, 20, 24, 26. 35.
One down. You have 3.
I think
This one? Which one, Elsa?
The one above that that says 4, wouldn't that only be 3?
1, 2, 3.
now it's 29. Wait. Because 5 plus 3 plus 16 plus 3.
Did I still not grab my calculator like an idiot? Dummy.
23, 25, 29, 34.
5
Okay, nobody can count cubes.
plus 3 plus 5 plus 4 plus 2 plus 4 plus 5. 34. Is that what y'all got now?
Yeah.
No?
Yeah.
If you're talking about me, I'm just shaking my head because I don't know how to count.
What about you, Elsa? Is that what you got?
I honestly don't know. I keep confusing myself.
All right, let's look at this one. I think I should get 2 more than that one.
Yeah, I got 36 on that one.
You got 36 on this one, yeah.
Would it be 2
By
more?
moving this
one
one
more?
over, I expose that side and that side now, right?
Oh, okay.
So you need more wrapping paper.
Thanks, Katie.
That's what Katie got.
All right, so that answers that question. Yeah, these are not easy to do, but I've seen these on, I think, 7th and 8th grade standardized tests, at least in Texas. I've seen those. Like, they'll ask them to find the surface area of something that looks like that. So. All right, let's look at this. So volumes of a regular rectangular right prism. So we have the length here of 8, the width of 4, and a height of 5. So if I was to break this apart, a good thing to use when y'all are teaching these are like Legos. That would be an easy thing for them to do, those nice little square Legos. Right? Y'all know what Legos are, right? Just making sure that's not past y'all's time or before. So yeah, so that would help with them trying to visualize what's actually happening with the concreteness of where this formula is coming from. Or we can translate it to kind of like how we did with a perimeter. We can condense the area of the base times the height. And usually that I've noticed on standardized tests, when they give formula sheets, this is the formula that they give. And this is also the baseline of like when we're looking at in calculus, is essentially this is what we're looking at, is looking at these areas and then stacking them over heights. And that's what the integral will do for us. For those of y'all who have taken calculus or will be taking calculus, that's the essentialness of where those formulas come up. So understanding just this baseline formula is important. And this can be extended to this idea. So if I have this rectangular box, so imagine like this is a stack of paper. And if I just knock the side of that stack, would I still keep the same amount of paper?
Yes.
Yes, so that doesn't change the volume, but the idea of looking at these in strips is, like I said, like the baseline of what's going on, what we do in calculus. So understanding just this concept here is a big idea. Because I actually use this simple idea when I teach Calculus 1. So, and 2, since we also did that beginning part of 2. So yeah. Then this is extended into what's considered Cavallari's principle. So 2 solids with the base and the same plane have equal volumes if every plane parallel to the base intersects the solids in cross sections of equal area. So if I looked at the cross section of this triangular prism, this would have, so that cross section here is just this side triangle, right? And this has 6. This is a 3. What is the area of that guy?
Well, you will have to find the other side.
A 9.
No, you wouldn't. Just get don't.
Because that's the altitude, right? So that's a 6 and that's a 3. So I don't need to find this guy, right?
Yeah, it just looked like the 6 is longer than the other side.
No, it's just based on how it was drawn.
Yeah.
So, Lauren, you said 18, right? Or did you
I
say
said
9?
9.
Yeah, thank you. And what about the little square that's inside there, his cross section?
9.
9, right? So no matter where I slice it, as long as I'm parallel to those bases, every cross section, it's saying that these should be the same, right? So assuming that these have the same height, so this has height h and this guy has height h, that would mean that their volumes would be exactly the same, right? So
Yes.
look at the volume of the triangular prism. That's base times height. Well, we figured out the area of the base is 9 times this hypothetical h. And if I look at the volume of the regular prism, that's base times height. Well, the area of the base is 9 times height. That make sense?
Yes.
Cool. So how would this relate?
The same.
So if these have the same height and these cross sections are the same, they should be the same, right? And same thing here. Same by Cavallari's principle. Now, these are the same, and these are the same, not to be confused that all of these are the same.
Wait, wouldn't they have to be not just intersects, but also bisects to be exactly the same?
You mean, one more time, Amelia?
So, like, if you look at that, you know, they could still be parallel, but be closer to that bottom line. 1 second, I'm sorry. The troubles of having pets at home while doing this. My cat this morning kept like racing back and forth behind me, so Yeah, I'm really sorry. We had someone coming over to our house and they just can't handle themselves. Okay, so my question was, so like the line, the what like cuts them, like what intersects them, it
Mhm.
could be parallel but be lower, and then like one section could be bigger than the other section. So like,
Right. So if we were under the assumption like this had, so this one is a rectangular prism, regular right prism, right?
yeah,
And this is the base and this was the height. And if I just slanted that guy, assuming this is base and this is still the height, make that look like an H, their areas are the same,
yeah,
assuming. Then if they're parallel, if I keep cutting in these cross sections, that those cross sections are always going to be the same based on his principle. If I have the same number of cross sections as I keep slicing and slicing and slicing and slicing going up this guy, it'll be exactly the same. So that's kind of like looking at this picture. Like if I take one of these individual pieces of paper and stack it on top of that piece of paper, it's still the same, right?
mhm,
But in this case, I just knocked the side of that ream of paper, but I will have each of those pieces of paper stacked up on top of each other.
okay,
Does that
gotcha.
make sense?
Mhm,
And so that's what's happening here is that if I slice these through these parallel planes, and if those cross sections are always the same, and I have each of those cross sections, assuming that we have a concrete number of these, that will end up saying that I'm stacking. So like that first slice, that's slice 1, slice 2, slice 3, slice 4, and up to each of them, H slices, the volume would be the H times those areas, no matter what, right?
gotcha.
That's what's happening here.
Okay, I get it now.
That
Thank you.
makes sense? And that same thing happens, like, so when we're talking about these slices up here, so like, for example, like if I have a shape that I created on an XY plane and I did something like, let's just make it some sort of bullet shaped thing and I rotated it around. So now I have this like weird oblong half hemisphere thing. And if I just take these slices and add up all of those areas, infinitely many of those guys, I can actually find the volume of that using some calculus stuff. So this whole idea of slicing, very important. Does that make sense? Granted, we probably won't teach a lot of this, like the details behind what's going on in elementary, but them being able to visualize this stuff, like I think them being able to understand that if I have this ream of paper and I change the shape of it just slightly, I'm not changing the volume. Does that make sense? Cool. So the volume of a prism is just going to be the volume is going to equal to the formula where we take the area of the base and multiply by the height. And of course, the base will be determined based on the shape of the base. Now, if we look at a cylinder, his base is a circle, so you could talk about it as a circular prism, but we have a special name for it. He has his own name as a cylinder, right? So take some time and think about how we would calculate the volume for these three figures.
I'm just thinking, like, would you find the volume of the base and then times it by the height?
You mean the area of the base?
Yeah, sorry.
Yes.
Like it'd be like for the rectangular prism, you could just do 3 times 10, which would be 30, and then times 15, because it'd be like all those slices.
Mm-hmm.
Okay. And then the same, yeah, for the other one.
Did y'all get them? So for the first one, I'll get 216 cm. Did y'all get that?
No, it should be cm cubed.
Thank you. There we go. I was waiting for somebody to correct that. Did y'all get that? 450?
Yes.
What about that guy?
Yes.
No, Amelia, why?
I think I must have plugged something in wrong. Like I have it written down correctly, but I must have plugged something in wrong on my calculator. I got like 785. So.
If you include the pi
Oh,
in there,
that's
you got
if you multiply by
785.
pi,
Oh, okay. So then I probably.
right?
Okay.
Yeah.
Yeah. Uh-huh.
250 times 3.14. Yeah, about 285-ish.
Okay.
So this would be exact. What you got is approximate.
Yes.
See, it just takes extra work to do the times of 3.14. So. But are we good with that? We're good? Yes, no, maybe so? Okay. All right. Now, if we look at volumes of pyramids and cones, if we look at this, if we figure out the formula for a volume of a prism, for some reason, if I look at the pyramid, it turns out to be 1/3 of that. Also the same thing if I look at the volume of a cylinder, but if I change it to a cone, I somehow get 1/3 of that. Where the hell do they get the 1/3 from?
Probably from some
Okay.
mathematician.
Your face. So let me see if I can find that video. Hold on real quick.
Oh, I know, because you had a cone and then you had a cylinder and then you filled them with water and you had an ice cream tub and you wanted to see how many ice cream cones you can make.
Let me see if I can find it. I had it up a while ago, and then for some reason I had to. Formula volume of pyramid. Pouring, I think, is what I found. Aha! There you are. All right. Turn you on. Now I need to share the screen.
The great enemy of
Oh.
writing isn't.
Skip ad. Pause. All right. Now new share. Basic screen 1. Share. All right. Do y'all see a video?
Yes.
Okay. Let's watch this.
Yeah.
So here's the pyramid and here's the rectangular prism. So if they fill up the pyramid, 1, 2, And come on, fill it up. 3. Isn't that neat?
That's exactly what I guessed.
Right. So you can do these, you can have a set like this for your classroom. I think this would be a good idea to have. You can also incorporate this into science a little bit and talking about units of measure. You could also do this like if you had these shapes and fill it up with Play-Doh and see like if you can fill up your box with 3 of those pyramids full of Play-Doh. Because that's an easy thing to do too.
Or
that
you
make
can
sense?
use slime.
Oh, you could use slime.
Kids love slime. I love slime.
All right. Why did it go back to the beginning? I paused it. All right, so now we have a triangular prism with another pyramid. One, two,
Oh, this one sounds good.
and 3. Boy, I got close on that one. Isn't that neat? And yeah, and then they have it with cone. So here you have a cone, and then you also have your cylinder. They're the same height, same base. One, two, come on, there we go. Isn't that neat? I never would have thought of that. So now change the share back to this guy. And move y'all back over here. All right. So that's where the 1/3 comes from. Granted, there's a much more complicated explanation to it than that. But this, by doing a simple activity like that, it'll kind of help reinforce the formula for the kids. So see if y'all can find the volumes of those guys.
Hang on, I gotta plug in my computer.
And also while you're at it, try the one with the net. And then this guy. So what did y'all get for the first one here? Let me resume share.
26.6.
What was the number?
26.6. Which is 80 over 3.
So what did y'all get for B?
120 pi centimeters cubed.
120 pi?
Yes, I think so. Why are you doubting me?
Should I doubt you?
I don't think so.
I got 12 pi times h.
Can we find H?
Oh, yeah, I definitely use a 10.
H is 8, isn't it?
I thought, oh, this should be 2, 6 times 2. So yeah, I should get 120, not 60. But that's not the case because the height here is not 10. That's the slant height, right?
Yeah,
Need the height here, and it's 8. Why is it 8?
because that's the Pythagorean theorem.
Right, because if I look at the triangle here, 6h 10 squared plus 6 squared, nope, equals 6 squared plus h squared. So 100 equals 36 plus h squared. 64 equals h squared. What number squared gives me 64? Not all say it at
6.
once.
Oh, 8, sorry.
There we go. Okay, cool. So that would mean that my formula for this guy, V, should equal pi times 6 squared times 8 now divided by 3. Which should
So would it
be
be 96 pi?
pi. Centimeters, right?
Yeah.
Yeah, just plain centimeters?
No.
No.
Centimeters cubed.
Cubed. Yeah, there we go. And for those of us who want to approximate it, what does that come out to be? Not a small number. 96 times 3.14.
Can you move the paper up a little bit, please?
Nope. It is where it is. Wait, this way?
Yeah, thank you.
Okay. I don't want it. Oh, something's going on with my touch screen here. Look, take that off. Uh, 301.44. Is that what y'all got? If y'all approximated?
I got it wrong, but we already knew that. But I get it, don't worry. I just did it
All right. Now, what
wrong. I'm
about
pretty sure I
this?
got this one right.
Huh?
I'm pretty sure I got this one right.
Okay. So here we're just given the base, right? How do I figure out the height?
Well, First of all of the triangles are equilaterals. So
Okay.
every side that you see right now is 10.
So that's a 10 and a 10. So
And then
I could look
there's
at this
zero.
triangle. As a 10, a 10, and a 10.
Yep, and then you can cut it in half.
So if I slant it up,
Yes, and then you have to make another triangle. I made 2 Pythagorean triangles. That's how I did it. I don't know if there's a better way.
so this is what it would look like if I folded it up, right?
Yes.
So if I take, so I need to know what, I need a different color. Where'd my other color pins go? Where's all my colors? There's my purple one, okay. So I need to figure out if I drop this straight down in there, I need to find that number, right? So there, if I make this little triangle here, that's inside there, right? This is right. Can I figure out this? So this piece should be 5, right?
Yes.
Okay. This is what I'm trying to find. What's this piece here?
10.
Is it 10?
Yes. Well, which one are you talking about? You're talking about that one in the middle now?
Because it's an
The-
equilateral.
The hypotenuse, right? So this is an equilateral triangle, right? So that's what that surface looks like, right?
Yeah. So
Is this also 10 here if I cut it
No.
in half?
No, that is the square root of 75.
So now I have a special right triangle, right? So this would be, so Sophie says that if this was a, I'll call it L since that's our slant height, L squared plus 5 squared should equal 10 squared, or L squared equals 75, which means L is the square root of 75, or 5 on the square root of 3, if I use special right triangles, right? The base times the square root of 3.
Yes.
All right, so there we got that.
Might be easier if you just leave it at 75 because then you have to square it again.
Huh?
You're going to have to square it again.
That's true too. All right, so I know I can interchange it like Sophie says, that I can leave it as square root of 75, which would make my calculations a little bit easier. Or I can have it in the simplified form, which means I have to make sure I squared each of those terms. So either way, won't matter. Okay, so now I know my height of my pyramid is either square root of 75 or 5 on root 3 centimeters, right?
No.
No?
No.
They're not centimeters?
Hang on. What are you trying to say? You're saying that the H is that?
Yeah.
But it's not. It was the hypotenuse should be that.
Oh, that's not right?
Are you trying to trick me?
The hypotenuse is 10, isn't it?
yeah.
So the height,
Because first you have to find the first triangle, okay, and then that's going to give you your slant height, and then you have to put that in the triangle again so you can get your height from the middle point so that you can actually.
okay, there we go. So this is here, right?
Yes.
Not there?
Yeah.
Okay. So now what is this going to be? So I take square root of 75 squared plus 5 squared equals, now my height squared, right? Or no?
No.
Square root of 75
You're being
squared.
lazy today.
See, I wish I had a chalkboard now. Like when I did this last time, I could be like, no, this is all wrong. And then that equals 5 squared plus 8 squared. Is that right?
Yes.
Okay, so that would mean 75 equals 25 plus 8 squared.
Yes.
So 8 squared is 50,
Yes.
or H is square root of 50. Or if you like to simplify your radicals, that's going to be 5 root 2.
Yes.
Now we have our height. So for the volume of a pyramid, 1/3 times the area of the base times the height. So that's going to be 1/3. What's the area of the base?
25. I mean, 100.
100 times, and then the height was square root of 50. So that's going to be
235.7.
cm cubed, which is approximately what?
235.7.
Is that what y'all got?
Yeah, I guess. I got 0.7, but
Huh?
pretty much the same. It's pretty much the same. I got
What did you
0.7, you got 0.6. It's a little bit different.
Oh, I didn't do it. I was going off of what you all said. Hold on. Square root 50 times 100. Whoa, what is happening? Square root of 50 times 100 divided by 3. Yeah, it should be 0.7. I thought I heard 0.6.
That might have been me. I think I was the only one who saw anything.
Okay. Are we good with that? Does that make sense? Maybe, Emily?
We'll get there.
What about you, Elsa? You also have a very stern look on your face.
I don't know. You lost me when you switched the height.
So here, when we found this root 75, this was actually the hypotenuse of that triangle. So this L belonged there. Should have done these two triangles in 2 different colors.
Okay.
Does that make sense? Do you see it?
No.
So when I looked at this triangle here, on this right side of that triangle, of that one of these lateral faces of that guy, the height of that triangle would have been my slant height of the pyramid. Does that make sense? So that would have meant that this slant height is now the hypotenuse of that triangle that's on the inside of the pyramid. Does that make sense? This is, when I've given this problem on a quiz or a test before, this is where they got them confused. is like this L is actually the hypotenuse of that triangle inside there. So in this case, L is actually a leg, but it's also the hypotenuse of that other triangle. So he's playing two roles.
So basically for this problem, we have to like cut the triangle in half once and then find a different triangle and then be able to find that triangle.
Right.
Okay.
So the purpose of this problem is, one, it's testing problem solving strategies. Like, can you actually talk your way through what's actually happening? What this information is telling me to get me the information to that triangle, which would give me the information to find the volume. So it's a layered problem. And two, of course, it just tests you on volume. So like here we need to know a couple of things, right? We need to know how to strategize. We need to know Pythagorean theorem. And then we also need to know volume. These are good problems that I would use as like an extension to when you teach volume. If you have these standards at your grade level, this is a good way to layer and do like a semi-summative assessment, because you are testing multiple ideas. Does that make sense? And you only gave them one problem. So these are good problems to use as like challenge rounds or on a final, because it will test multiple concepts.
They're like puzzles.
So yeah. All right. Now, volume of a sphere comes from imagining that if I created these n-sided cones inside this sphere and then stack them all together, like there's like this Christmas decoration where they use like Solo cups, clear Solo cups, and they put Christmas lights in them. Have y'all ever seen those?
Yeah, are you talking about when they make the snowman too?
Yeah,
Or-
like you make these, like, so
Yeah.
they end up making these spheres out of these Solo cups. Essentially, that's what you're doing here. Or like if you wrap like pretty shiny paper and make these cones out of them and then put them together, it looks like this big flowery ball.
Mhm.
Seen them on Pinterest when I was looking at wedding decorations. So this is essentially what they're doing here, is that they're imagining that you put these cones together and put infinitely many of them throughout this thing. And then as I take the limit, as that n keeps growing, that this will eventually converge to this formula here. So if we had the surface area of a sphere, so that's where the 4/3 comes from, is that using that volume of the cone and then also translating it to what we know about spheres. I'm not going to test you on that. That's just where they came up with the formula. And like, I learned more about this when I did calculus. Yes, Sophie.
When I learned about this in geometry in 10th grade, my geometry teacher talked about baseballs.
Baseballs.
Because like how they have those little shapes on them. You know what I'm talking about? Like you can, if you like rip it apart, then you have those two little 8 things. You know what I'm talking about?
When I rip a baseball or softball apart, it's layers. You have the
Never mind.
leather part,
Continue on. I was just trying to help.
and then you have the wrapping around it, and then you have the cork in the middle.
It's okay, just keep going.
Okay. So this is, so you just need to know this. That's all I care about. Right? Okay. So, given this word problem, Find the volume of a sphere whose radius is 6 centimeters. So from the formula for a sphere, that's going to be 4/3 pi r cubed, right? So what does that 6 mean?
You're frozen on my thing, Joni.
Oh no. Y'all see me? Hold on. Okay. Now do y'all see me? I see y'all
Yeah.
moving. Y'all
I
froze
can
on
see
me
the
too.
face moving, but not your hand. Does that make sense? Oh, now it goes.
There we go.
Okay. Yeah, y'all were all sitting still too. I was like, what happened?
Well, we were all talking to each other about how you were frozen.
Oh, sorry. All right. So here, what does that 6 mean?
That is the radius.
That's
That's the
who?
R.
That's the
That's
R,
gonna
right?
be
So all
R
I'm going to do
cubed.
is plug that in. And then that's going to be
288 centimeters.
6 times 6 times 6 times
Uh-oh.
4 divided by 3. So what you got?
Yes.
And what is that approximately? Since I know a lot of y'all like to do the approximately.
Approximately 904.7.
Right?
No, 7, not 3, 7. Well, I pushed the pi button.
Oh, I cheated because I don't have the pi button on my phone calculator because I left my calculator in the other room.
That's okay.
I guess I could have snuck out when I froze the screen. But. All right, so that is essentially volume for formulas wise. Now let's talk about converting. So here we have the same idea of like when we were talking about converting areas. Now we're converting in a third dimension. So if I was looking at a decimeter sided cube, this would be 1 decimeter or 1 cubic decimeter. But if I wanted to translate that into centimeters, well, 1 decimeter is equal to 10 centimeters, and 10 centimeters and 10 centimeters. So a lot of students would see this and they think, oh, convert it into cubic centimeters. They would just convert it by 1 decimal place as opposed to the 1, 2, 3 decimal places that we need to convert it to. Right? Like a common mistake would be like this would translate into 10 cubic centimeters, which is wrong. Because obviously we see it's 1,000. They will only convert 1 of those units instead of all 3 of those units. Does that make sense? Cool. Same thing here. So if I was taking 1 cubic meter and changing it to cubic centimeters, I would convert every single one of those sides to see that I would get 1 million cubic centimeters as opposed to just saying 100 cubic centimeters, which is a very common mistake that students would do. And then also going from decimeters to meters, I would move everything over by that 1 decimal place to the left to make it smaller, which would be 0.001 cubic meters as opposed to 0.1 cubic meters. So let's see what we would get if we would convert 5 cubic meters into cubic centimeters. So you could use this chart, or you could use the idea of just doing a conversion of one at a time. That's how I see it. So if I see 5 cubic meters, I'm going to do 5 times 1 meter times 1 meter times 1 meter. And I'm going to centimeters, so that'd be 5 times 100 centimeters times 100 centimeters times 100 centimeters. So that should give me 5 with 1, 2, 3, 4, 5, 6 zeros. So it'd be 5 million cubic centimeters. You don't have to do it this way. I just think it's easy to visualize what's actually happening with the conversions at each unit. And you would obviously see that you would have a centimeter times a centimeter times a centimeter, which is 3 centimeters multiplied together, or centimeters cubed. Right?
I agree.
Cool. What about this one? What would we get?
You would have to multiply it by a decimal now. 0.1. So you move it over.
Right, because to go from millimeters to centimeters, I'm moving back to the left by 1 decimal place as opposed to increasing it, right? So when I'm going from a smaller unit to a bigger unit, the number should decrease. So if I had 1, 2, 3, 0, 0, and then 1 millimeter times 1 millimeter times 1 millimeter. That's the same thing as 12,300 times, and then to go from millimeters to centimeters, that's moving it to the left by 1 decimal place, right? And I won't use the dots here so I don't get it confused with my decimals. So this number here is technically 0.001, right? Oh, 0. There we go. 1, 2, 3. 1. That's 4. I feel like that's not right. I don't believe you, book. No, it is. Right? 0.1 times 0.1 times 0.1. Yeah. 3 decimal, not 4. Okay. Wrote my notes wrong here. Okay, so here, if I'm moving it over 1, 2, 3, 1, 2, 3.
I'm in math class.
Huh?
Sorry, I'm talking to my mom.
Oh, sorry. So 12.3?
That's what I got.
Cool. Awesome. Yeah. So these are things that when you present these in class, I would show them like what would happen when we convert each single one of those measurements. And it would be helpful if you had like one of these cubes and you could actually label them as such, so that way then you can actually break those apart better for them. All right, so in the metric system, they also have other units of measure besides like cubic centimeters and cubic meters and all that stuff. They also have what's considered based on dry or liquid measures. So they have liters. So 1 liter is equal to 1 cubic decimeter. And of course, we use L for liter. I was told that it's not the same, but Sarah, you're from Canada, right? Y'all use liters, right?
Yeah.
Yeah, and y'all use L for that?
Mhm.
Okay, so yeah. I don't know where it's not, because I haven't seen it where they use some other label for liter. So, couldn't find it. Also, hectoliters and deciliters aren't commonly used, and deciliters, you'll see these. And from what I recall from chemistry and genetics and all that, when we were doing labs, we only used kiloliters, centiliters, and milliliters. So I went back through my notes and I couldn't find where we would ever use those. So convert the following. So if I have 27 liters, so these are still based on the powers of 10 rule. So if I have 27 liters, and I can use my dimensional analysis on this. So for 27 liters, for every 1 liter, I would have 1,000, right? Milliliters. Because that's my special one. So that would make that 27,000 milliliters. What would 3 cubic meters be in a liter? How would I do that problem? Do I have that conversion somewhere? It's not on my chart, but I have this one, right? I was told this fact. So could I use that fact to find this?
Yes,
Yes.
you could. It just sounds annoying.
Right, so if I have 3 cubic meters, for 1 cubic meter, I would have 1,000 deciliters or decimeters, right?
I concur. Yes, I agree.
And then for every 1 cubic decimeter, I have 1 liter, right?
Yes.
So I'd see the meters cancel, decimeters cancel, so I'm left with the units of liter. So that would give me 3,000 liters. See if y'all can do the next two for me.
Where did the 1,000 decameters cubed come from?
Oh, good question. So if I was to convert 1 meter, that is 10 decimeters, right? So if I take 1 meter times 1 meter times 1 meter, that gives me cubic meters, right? So that's going to be 10 decimeters times 10 decimeters times 10 decimeters, or 1 cubic meter is equal to 1 and then 1, 2, 3 zeros cubic decimeters. Does that make sense?
Yes.
Cool. All right, see if y'all can do C and D for me. I'm going to pause this and I'm going to go get my calculator. Oh. Coming back, you didn't have to get up. I'm not leaving you. Come on. Ah, damn it. Typos. So did we get 3?
Yes.
Yep.
And what about this one?
Yes.
Yes.
I like that one. That one was easy.
All
We just
right.
have a test of nothing but these.
You say that now.
Of the easy ones.
Can you work through?
Oh, okay. Just the easy one.
I don't like those.
Can you work through C, Yoni?
Yeah, sure. So I have 3 milliliters. And for every 1 milliliter, I get 1 cubic centimeter. So why is that?
Because it's just straight facts.
So if I use this idea, right?
Right.
And that is a fact, but why is that a fact?
Because if you move them, so that one goes to milliliters, and then the other one goes to centimeters, it's still the same like comparison thing. You know what I'm saying?
Right. So if I change, so 1 liter is equal to 1 decimeter times 1 decimeter times 1 decimeter. And I'm going to centimeters, right? So that would make that a 10. Oh, centimeters, right? The 1 liter is going to be 1,000 cubic centimeters, right? But if I want to change this to milliliters, that would mean I would multiply each side times 10 to the -3. That would be moving the decimal place over to the left by 3 units, right? So 1 liter So if I have less than that, well, that's not the right way to explain that. I want to convert that to milliliters. So let's go backwards. So if I want to take 1 liter and multiply by and change that, so for every 1 liter, there's 1,000 milliliters, right? So 1 liter is equal to 1,000 milliliters. Which is equal, from that conversion that we did up here, is equal to 10,000 cubic centimeters, right? This is Amelia's question, right? I lost her.
Yes, it was. Sorry.
Okay.
Yep.
Okay. So does this make sense?
Yes.
So if I have 1,000 milliliters equals 1,000 cubic centimeters. If I want to take this to 1 milliliter, that would mean I would divide this side by 1,000, right?
Mm-hmm.
And if I want to, so if I do one side, I have to do the other side. So if I divide this side by 1,000, I would get 1 cubic centimeter.
Gotcha.
So that's where that conversion factor came from.
Okay. Thank you.
I feel like that took longer than it should have for me to explain that. I have to think about improving that. But did that work? Are you okay with that explanation?
Yes.
Okay, cool. All right. Oh, we hit the 120
What
mark.
time?
It's time. I didn't feel like that we were here that long.
I did.
Oh, sorry.
Sorry, it just feels like it's so much longer when I'm in my room.
Oh,
Does that make sense?
oh,
When
I
we're
felt
on
like we
house
were
arrest.
accomplishing so much stuff, and it was like we were being productive. I like it.
Okay, great. Thanks. Have a nice day.
All right. So we'll pick up this stuff on Thursday, and I will work on getting a quiz for y'all. I know some of y'all are having some troubles uploading that quiz. So
Yeah, I couldn't find it anywhere.
what?
Well, I also looked on Saturday.
Oh.
And I haven't looked again since.
I've just emailed mine to you.
Yeah, I saw that you emailed it to me, so that works too. So, but I think you can upload JPEGs or PNG files to that as well, because I didn't put any restrictions on what kind of files you should be able to upload.
Okay.
So, but yeah, but I got it, Emily. So,
Okay.
and Sophie, do you need help finding it?
No, I'm sure I can find it. I just haven't looked since Saturday.
It's under the written
I
assignments.
low-key
and
forgot.
uploads.
I remembered on Saturday, and then it wasn't there, so I forgot. Okay.
Gotcha.
Yeah.
And then we have a article
Yes.
reflection due Friday. Yeah.
Yeah, I think that's right.
Make my life so
But-
hard.
Do what, Sophie?
I said you make my life so hard.
I'm sorry. I'm sorry. That's
Do
my
we-
only goal in life was to make your life complicated. So, yeah. So try to get keep working on things. I'm working on trying to figure out how to give y'all feedback on lesson plans. So I'm working on that. I also working on y'all's midterm grades today, so y'all will have those. So yeah.
Forgot we took a midterm.
Also start working on getting with your advisors, of course. I mean, I'm not y'all's advisor, but make sure y'all are getting in contact with them because the schedules have been kind of wonky with all of this online stuff. So you're gonna have to do your meetings online. Also,
You're right.
No, we can still register the 30th, correct?
right. Yeah,
Okay.
that's still in the works. Also, they are converting all summer classes to be online classes. So if you're taking summer classes, they're going to be like this again too. I know, bummer. But I'm hoping this whole craziness will be over by this summer. So
So, okay, housing also sent us like emails. So, like, I left, but half of my stuff is still like on campus. Do I have to wait until all this stuff is over to go get it?
So there is a rule that says that you can go from residence to residence. So you're able to travel between residencies, but I would try to avoid leaving as much as possible. So
Okay, because like I'm at home 4.5 hours away.
right.
So like,
I wouldn't rush back.
okay,
Hopefully by the I'm hoping by the end of the first week of April we'll have some more calmness to all of this, because I'm just hoping that after this week and next week, things will have slowed with the progression of that virus. So we're just hoping.
okay.
So
It just stressed me out because my RA came up and she's like, yeah, would it be okay if we use this if someone got sick as like, they can use this as their quarantine place? I'm like, sure, I guess.
yeah, assuming that they'll disinfect your stuff after it's over.
Yeah.
So, yeah. And I know that those are things that they are making arrangements for on campus and stuff. So, yeah, just don't go out unless you have to. But there is something in there about you can go from residence to residence, because we have a faculty member who has a house in Traverse City who has a house like in Grand Rapids as well. So, and she's going between residencies to make sure everything is okay while all this is going on. So, yeah. But y'all
I
stay
need
safe.
so many houses.
I don't know how she has 3 houses. I can barely afford the one I live in right now. So, but yeah. All right. So I'm going to stop recording this so we don't have these nonsense conversations on here.
Okay, and I have to go.